Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today my topic is about Android and security. The outlines are introduction to Android, assumption, Android architecture, trust boundaries from the developer perspective, security model and its advantages and disadvantages, vulnerabilities and threats at the client side, guides and best practices to develop apps. Introduction to Android. It is a mobile operating system developed by Google. It is written in Java, C, C++, and others. The current release is version 9. Marketing targets smartphones, tablet computers, smart TVs. In the previous year, it has 2 billion monthly active users. Primary store for downloading and installing apps is Google Play. Google Play has more than 3 million.3 apps. The assumption here is that the reader or listener has basic knowledge about Java, Android components such as activities, intents, etc. Android architecture is a layered architecture or hierarchical. I'll start from the Linux kernel. Android is built based on Linux operating system. Linux kernel allows device manufacturers to develop hardware drivers on the platform. Hardware abstraction layer, which is the second layer, it provides interfaces to use the hardware resources such as the camera, Bluetooth, as Java APIs. Android runtime consists of art core libraries as well as the native libraries. It is the second layer. The libraries that exist in any Linux system, which I am talking about the native libraries. These are the libraries that exist in any Linux system, including SQLite for databases and others to record and play videos, draw 2-dimensional and 3-dimensional, etc. For devices running Android version 5 or higher, each app runs in its own process and with its own instance of the Android runtime. For devices running Android versions older than 5, it is the same, but they are running on Dalvik virtual machine. This will be explained further in the security section. Core libraries. This category encompasses those Java-based libraries that are specific to Android development. Examples of libraries in this category include the application framework libraries, in addition to those that facilitate user interface building, graphics drawing, and database access. The Java API framework. The application framework layer provides many higher-level services to applications in the form of Java classes. Application developers are allowed to make use of these services in their applications, such as Activity Manager, Content Providers, Resources Manager, etc. Apps and System Apps, this is the top layer. They make use of the Java API framework to use the entire capabilities provided by the lower layers. These are the apps that the user interacts with directly or indirectly. System apps comes installed by the manufacturer or vendors, and the apps are the ones installed by the user. The trust boundaries from the developer perspective. The trust boundaries for the developer is the application itself. You trust your own app, but you can't trust other components, whether you communicate with or use in your app or even other apps exist on the phone. The trust boundaries are application-centric, not user-centric, which means you don't trust the user of your app. The following section will make things clearer. Security model in Android. The security model consists of two layers: operating system security model and the application security model. Our concern as developers here is the application security model, since it is the part that we trust. The security model for apps in Android consists mainly of 4 components: the sandbox, permissions, TEE, explicit intent. Let's first talk about sandboxing. In order to secure app, preventing app from attacking another app, preventing issues in an app like bugs to cause problems to other processes within the system, Android uses sandboxing technique, which means that each app runs in its isolated process with its own instance of the Android runtime or Dalvik in older versions. The app has a unique identity and its unique instance of art in Android runtime. In the application sandbox, an app can write its private data, like databases and files. Starting from Android 4.3, the sandbox security was enhanced by adopting security enhanced. It operates on the basis of denial by default, whitelisting. So any security-related actions must be explicitly approved. This makes sure that other apps can't assign permissions to other apps to access their data. This protects against privilege escalation attacks. Android uses standard Linux file-based permissions to protect apps files, unless they are explicitly exported outside their sandboxes. They can't be read or altered. In order for an app to communicate with the outside world, an app must have permissions that allows it to do its intended work. Before talking about permissions, remember, activities are the entry point for a user interaction. Manage navigation within the app. Services, long-running operations in background without user interface. Broadcast receivers, send or receive broadcast messages from operating system or apps to indicate an occurring events. Permissions. The permissions are a key building block for security in Android app to access resources and data. To access them, the permissions must be required explicitly. Normal permissions cover areas where your app needs to access data or resources outside the app sandbox, but where there is a very little risk to the user's privacy or the operation of other apps. For example, permission to set the time zone is a normal permission. Now let's talk about dangerous permissions. They are permissions for high-risk operations, like accessing private information on the device or have access to capabilities and resources that can pose risk to users' info or device operations. This, of course, requires explicit user permission. An example, access the camera. Signature permissions. It allows app B, for example, to use another app's perform an operation only if app B has the same signature as the app that defined the permission, which is A in this case, which means usually that the owner of the app A is the same owner of app B. Custom permissions, the app can share its resources and capabilities with other apps. To secure the process, an app can use custom permissions defined by the app owner. Then the system will use the signature permission mechanism to allow or reject a request to the requested permission. Security advantages and disadvantages of permissions in the eyes of developers, not end users. Advantages: it prevents other apps from accessing your app data without permission. Permission allow your app to communicate with your other apps your other apps only securely using signature permission. It allows your app to access other apps' exported data. It allows you to give permission to another app to take your data, process it, give the result back for only one time. For example, per URL permissions. Disadvantages: versions before 5 have a vulnerability called custom permission problem. It allows malicious app to gain access to your app via your defined custom permission by providing a permission in their app that has the same name. It is similar to namespace problem in JavaScript. The third component is Trusted Execution Environment, or T. This standard is established by a global platform that provides a common interface specification for the use of hardware security capabilities. It enables hardware-based security, where things like cryptography or memory management exist. Android uses two virtual processors, an unsecure and a secure core. The main processors run on Android run on the non-secure processor, which can access only non-secure related system resources. The secure processor can see and access all resources. So if an app wants to access security related processes, the RE will ask the T to provide the service. The T runs in the secure core, which has social services run to service requests from outside, and RE runs in the non-secure core. Building trusted applications, or TAs, to run inside the T is currently limited to vendors, but Samsung has developed their architecture to enable the usage of T for enterprise. Google has started to adopt some of their architecture in Android. Can you see any security problem with the code developed below? Are the algorithms used for the encryption secure? Remember that you are developing using Java at the client side. The code can be recovered very easily by any decompiler tool such as JADX or Show Java app. They must not contain secrets or sensitive data. Another threat is web view. Web views are used to run URLs in your app. If JavaScript is enabled, your app might be exposed to attack like cross-site scripting attacks, which will increase the attack surface to your app. Another threat is repackaging your app and republish it. A malicious developer might decompile your code, tampering with the source code, republish it as it was developed by you, compromise the user's privacy, or even attack your servers using the information available in your app. He might earn through adding ads, for example, or change the payment mechanism for his own. Statistics shows that 80% of malwares comes with the repackaged apps. Threats can come with the operating system itself. So for example, stage fright exploit. It was detected in 2015. Billions of Android handsets could be controlled without their owner's knowledge. The attacker sends a video via MMS text message to an app such as Google Hangouts. The malicious code runs and take over the exploit. So this gives you an overview that the operating system and the underlying components can be compromised. So they must be out of the trust boundaries and validated when needed. Now let's talk about guides and best practices to develop apps to analyze and mitigate weaknesses. Let's talk about this framework. It is a framework for designing and implementing a secure mobile apps, as well as making them difficult to reverse engineering and limiting available information. It is created by Northwest University. First, on the top, it starts with the security features provided by Android. Then, on the middle left, tools that we can use to perform static or dynamic or network analysis to identify information that we might exposing to the public. The right side are used to validate the integrity of the running environment. The rest of the at the bottom are techniques that are used during design and implementation phases. We'll talk about some of these tools since we have talked about the top level. We can talk about the other tools briefly. JADX, it is used to decompile the code and see which information are being exposed to the public. As you can see, you can read the code of all classes written in Java. Browser is a dynamic tool to analyze apps vulnerabilities, attack surface, view permissions, and also test the permissions of exported components like activities and many other security related things. The tool can be used also to test apps that you didn't develop yourself. Here are some snippets of the testing Slack app. The next tool is packet capture. It is an app used to capture traffic and recovering network traffic to and from the application and determine the strength of the network security in the application, like encryption, for example. Packet capture includes an SSL stripping option to recover plain text out of the receiver. Anti-tampering. Now we are on the right side of the framework or the model. Signing app in Android doesn't provide authenticity, but it makes sure that the developer who signed the app when it is first published is the same one who published updates later. But still, the app might be decompiled and built again, published on third-party store or websites. To make this process harder and costly for attackers, you can get the signature of the app certificate prior to release, and they can then checking it at the runtime and do whatever you want if the checking fails, like notifying the user, for example. Of course, the checker code might be discovered, but it makes things harder, especially if you implement this technique in the code from the start, making it very time-consuming to remove. Google Safety Net can be used to detect the integrity of the code. Anti-reverse engineering. The purpose of securing code in our apps is to protect against unauthorized injection of malicious code, theft or intellectual property by extracting and reusing the code, invasion of users' privacy, theft of activation codes and credentials for financial gain, cheating in competitive apps. The following are techniques to be used when designing and developing your app, but they must be used with caution because they might make maintenance and analyzing hard. Also, these techniques must not be relied on to secure your app assets. They are just to make reverse engineering harder and expensive. The first technique is bytecode encryption. It is used to encrypt the methods and then decrypt them. You can use decrypting methods that you made beforehand to get the original code again. Dynamic loading. It can be used to download the classes from external source at the runtime. These classes are downloaded in the form of DIX classes that are not readable by humans, but it has the risk of being manipulated. But you can use several DIX methods to ensure the integrity of the files. Lexical obfuscation, which change the variable and methods names to machine labels that can't be understood by humans. The change in names will happen only to the developed app or to the deployed app, which removes any maintenance problems. ProGuard. It is a tool that provides such a feature, although it is mainly used to minify the app size rather than mitigating reverse engineering. Other techniques to analyze the app. You can use Android Lint to test your application against security. It is a static analysis tool. You can also write unit tests to validate your security mechanisms. Now let's talk about best practices when developing Android apps. First, make sure to not export an activity unless you needed to do that. And make sure to provide permission to restrict the access to your trusted apps. This will minimize the attack surface. Try to use explicit intents rather than implicit intents to make sure the app that's processing your requests isn't malicious. If you use implicit intents, make sure to validate the data before processing them. Use custom permissions to services and broadcast receivers to restrict the access to only your trusted apps. Also, if you want to export your data to other apps, use content providers to control the access. And don't forget to validate the user's input by using parameterized queries to prevent SQL injection attacks. If you are exporting to your other apps only, use signature permissions. In web views that allow you to open websites in your app, avoid allowing JavaScript code to run by calling set JavaScript enabled. This helps the attack, such as cross-site scripting. If you need to enable the JavaScript in your web view, then ensure the websites are trustworthy. And avoid dynamically loading external code to prevent loading malicious content with your classes. Declare data as final. Immutability. Make sure no change happens to the data. When creating a file that contains data that shouldn't be exposed, make sure to create it inside the app's sandbox to protect it from unauthorized access. So get files directory is the app sandbox path in the mobile application. Of course, this might not be enough, so it is better to encrypt the content as well. If it is sensitive data. To store keys and credentials, use KeyStore, which is an Android mechanism for managing sensitive key, which is used to store secret keys, private keys, trusted certificates. When using Google Map keys, make sure to restrict it to be used with your app only and prevent others from using it. You restrict the key to your app's package name and SHA one signing certificate fingerprint. Native code, which written in C or C++, can be used to prevent the code to appear in the decompilation process. If an attacker wants to reverse engineering the code, he needs to go to the assembly level and perform reverse engineering. Security for enterprise. Use Android for work, which enables enterprise security. Some of the features provided are manage the profile settings to be managed by profile administrator, which controls which apps and features can be used on the device. Manage configuration settings to be managed by administrators, like whitelisting or blacklisting URLs. It also has the feature of single-purpose devices. Enable devices to boot to a single app and cannot escape from it. And these are the references. Assalamu alaikum.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is FAWZI Al-Nono. I will represent for you today ASP.NET technology as my presentation topic. The outline for this presentation will be a brief introduction about the ASP.NET technology, the top vulnerabilities from OWASP, apply and how are they applied to ASP.NET, and how to mitigate them. I choose from those 10 only 4 because of the time. We will discuss injection, how they are applied, what are the advantages and disadvantages allowed in the ASP technology to mitigate injection. Also cross-site scripting, broken authentication, security misconfiguration, type of authentication in ASP, and this could be considered as an advantage of using ASP technology in terms of security, because there is more than one type of authentication. And references, not the references that I used, but references for those who are interested in reading more about the topics. I used them, but not all the references that I used in this presentation. Okay, an introduction about ASP. Okay, ASP stands for Active Server Pages. It was introduced in 1998. It's the first Microsoft server-side scripting language. So basically, it's like PHP to those who took web development courses. It was, but we are talking about ASP Classic. Now, ASP.NET was released in 2002 as a successor to Classic ASP. Also, you can see the differences of in web pages that Classic ASP pages extension is .asp, while ASP.NET extensions are .aspx, and also they are written in C#. Now the top vulnerabilities based on OWASP, and this is the updated one. The first one is injection, broken authentication, sensitive data exposure, and so on. I will take only 4 of them, which are injection, broken authentication, security misconfiguration, cross-site scripting. I'm not going to handle them by this order, because the coding part is in injection and cross-site scripting, and there's some coding in the broken authentication, but I'm focusing on the injection and cross-site scripting as an exercise, or you can say a tutorial. The injection. On the injection, I assume everyone knows what is injection, so I'm not going to spend a lot of time explain it. But in case someone still have a vivid definition for it, I will give you the quick definition. It is allowing the attacker to submit a malicious code to the back end which influences the behavior of the system. This could lead to information disclosure, could also lead to denial of service, and so on. Our focus in this injection will be the SQL injection. Of course, there's a lot of other types of injections, but this is the most familiar or famous injection type. And now for the example and the injection. This is a database, 2 tables in the database, and for the sake of simplicity, we used this form of databases, and this database is Northwind database. Okay. Also, we will use the what's called beverages category, which happens to be category ID 1. This is the code. You can see in the first line, cat ID request query string category ID. This is where we will take the ID of the category, which in our case is 1, and the following commands are to perform it in that database server. So if you're taking PHP and the web development, it's almost familiar with the same. They have a lot of similarities, because you will define a cat ID and put it in the string select star from products where category ID equal, which in our case category ID is number 1, and then send it to the database and retrieve the data from the database and show it to the user. And this is the result. You can see on the link above the category ID equal 1. It's like the get method in PHP. This is also this is where you can start injection your SQL. The highlighted in red statements are the untrusted data, and it is shown in both the context of requested URL and subsequent SQL statement. So you cannot. So the category ID itself, the value of the category ID itself, cannot be trusted. The problem with the construction of this code is that by manipulating the query string value, we can manipulate the command executed against the database. So if you change the category ID value in the URL, you can affect the database command. Okay, you can see here these are some simple examples about injection. Products ASP, see in the third line, when category ID equal 1 or 1 equal 1. This will lead to disclosure of all the data in the database, because 1 always equal 1. So this condition will disclose information. Also, you can in the last, not the last line, the above it one, the category ID equal 1 or name equal space. This could lead, this most probably will, when this statement runs against the database, it's going to fail, because the products table has no column called name. See? So a product name, not name itself. So the resulting of this, the web application is going to return an error to the user. Hopefully it will handle it correctly, otherwise it will crashes. And this could be useful to know what types of information in the database itself. So if I tried by luck product name, this will tell me that there is a product name column in the products, and so on. I can try it what the common names in my on my mind, and this will lead to discover how what are the columns in the my table. Okay. Now, on this until now, with the previous injections, it is only retrieving data from the database. The first thing to note about the injection above is that we are now executing multiple statements. You see, and after the one, there's a semicolon, then the update product set product name equal product name. This will update the product name, and which will be considered as one of the stride thread modeling, which is tempering. You can see the first line is what is written in the URL, and the second one is what is going to be performed in the database. Now, how to mitigate injection? There are I listed only four, but there's a lot more than this, but they are the most widely used, and I will only explain two of them because of the time, which are validate all input against a whitelist and parameterized stored procedures. Okay, validate all input against a whitelist. We need to have the assumption that must always be made that any data entering the system is malicious, and unless it's proven otherwise. And this is the concept of whitelisting. The data might come from query strings like we just saw, or from form variables, or even request headers. Validating all input against whitelists is both far more secure and much easier to implement than blacklisting. In the case we just saw before this slide, we only expected a positive integer, and anything outside that pattern should have been immediate cause for concern. And this is how we should validate the input. First, we define the range, and then don't allow anything outside this range to pass by. Just this one piece of simple validation has a major impact of the security of the code. It immediately prevents all the examples further up completely worthless. So, you see in the second line, var positive integer regs. This specifies that the range that I am expecting for the category ID is a positive number. So from 1 to 9, or from 0 to 9. Otherwise, it will show the user an invalid category ID has been specified. So you only allow him to enter the ID. He can't use 1 equal 1 or anything else, or 1 semicolon update, which is almost protecting your database from manipulation or tampering. Now for parameterized stored procedures, in the left side, create procedure get products, add category ID. It's creating a procedure to solve one of the problems we had above, which was that the query was simply a string generated dynamically at runtime. The account used to connect to SQL server then needed broad permissions to perform whatever action was instructed by the SQL statement. I'm talking now about the example that I showed before, not the how to mitigate the injection. Let's take a look at the stored procedure approach on the left side on how it protects against SQL injection. First, we will put together the SQL to create the procedure and grant execute rights to the user. So we will write the left side on the server side, on the database server side. You are only specified the category ID as an integer. And if it wasn't an integer, you can see in the second line, you are specifying it as an integer. If it wasn't an integer, then in the where condition, you are you put grant execute. It's like an exception that it's not an integer, so deal with it. So most probably you will send a message like the other code, the other example about before this one. In the right side is the code in the ASP document, our server. It's most probably the same, but you will use the command parameters.add category ID, which are specified in the server side as an integer. So if it receives anything other than an integer, it will not perform the invalid or malicious code. Now for the cross-site scripting, it allows the attackers to execute scripts in the victim browser, which can hijack user sessions, defect websites, or redirect the user to a malicious sites based on OWASP definition. You can see the state. You can see Here you can see the status bar telling us the link is going to take us to ASP.NET, which is the value of the URL parameter in the bar location. And above it is the code of performing it as an ASP, not as defining it as HTML tag. This eventually will translate it to be an HTML tag on the client side, like this, like you are seeing now in the last line. You do the above code, and it will eventually translate it to an HTML tag. So here you can, by starting manipulating the data in the query string and including code, this is what happens. See the continue word. In the previous one it was only continue. Now it's XSS bigger than continue. So what happened is that we've managed to close off the opening tag and add the text XSS by editing the hyperlink tag context and entered an all new context. This is referred to as injecting up. The code then attempts to close the tag again, which is why we get the greater than symbol. Although this doesn't appear particularly threatening, what we've just done is manipulating the markup structure of the page. Okay, this is a problem, because if I can manipulate it. So in this example, the header style was put to display none. So you can see the continue word is now not a valid hyperlink. So it's only a text. So you manipulate the style. Furthermore, inspecting the HTML source code disclosed the ID of the log in link, and it only takes a little bit of JavaScript to reference the object and change the target location of the link, as it's shown in the URL. What we've got now is a website which will cause the login link to take the user to another website. That website may then recreate the branding of the original and include username and password boxes, which then save the credentials to that site. How to mitigate cross-site scripting. Also, validate all input against a whitelist. Always use request validation and use anti-XSS. I will discuss only the first and last two. Also, there's a lot more mitigation ways or methods, but I'm focusing on those. I will talk about anti-XSS now. It's a Microsoft anti-cross-site scripting library. It's implemented and embedded into the ASP.NET technology. It uses encoding algorithms for HTML, XML, CSS, and of course JavaScript. If you use this library, you can prevent, or not prevent, you can say minimize or reduce the cross-site scripting threat to your site. And this is one of the advantages of using ASP.NET as your technology for developing website. Of course, the advantage of in security terms. And for validate all input against a whitelist. It is a little easier in .NET because we have the URL.isWell-formed URI string. Okay, this is a method that also is defined in ASP.NET. This method is to validate the address and put it as an absolute. This also can be performed so by using this method, you can put meaning of putting it absolute is you cannot change it, like the final word in the Java coding. When you put a variable, when you set it to final, so it's absolute. You cannot, it's something that will not change, like the pi variable. So this method, when you use it, it's hard to change the website that you specify it as an absolute, and also it's considered as a validation for the input. And this is a way in ASP.NET, but also you can use the previous way that we used in the injection part here also to validate the input, or in this case the URL. Broken authentication as session management. Okay, if I will reduce it because of the time. Broken authentication, it's when your credential are taken away or stolen by the attacker. The attacker can use your session to steal your credential. And one of the things that in ASP.NET will allow the attackers to steal your session information is if you are not using cookies to specify sessions. Okay, because of the time I will skip the exercise. These are one of the mitigations techniques. As I told you, if the user want to take your it's easy for the user to cookieless sessions, to steal credentials from cookieless sessions. Could be the cookieless sessions can be used in the configuration file of your web application. But it's always better to use the cookies for the session. Also, always put an expiration date for the session. For example, after 30 minutes, the session is over, to limit the user, to limit the attacker from doing whatever he wants in the system. Also, and for the broken authentication mitigation, always encrypt your data. Always encrypt them, even if you put them in the session. I think there's some ways that you can encrypt your data. In security misconfiguration, as we were taught in this course, don't rely on default configuration. Always change the configuration, even your configuration, your server's configuration. Always change them, always update them, because they can be used they can use by the attacker to be exploited. So how to mitigate them is keep your frameworks up to date, customize your error messages, disable debugging, And types of authentication in ASP.NET is one that I found it fascinating, because it has more than one authentication method. This you can use all of them to use defense in depth or layering. And the following and the references you will I put it a link. I wanted to to make it work and see and let you watch a video, but because of the time I need to skip it. But if you are interested, you can see it. And this book, the first reference is a book that talk about all the 10 OWASP vulnerabilities for ASP specifically, and how to mitigate them. And thank you.
Hello everyone, I am Hussam Shbib from Prince Sultan University, and I am going to talk about security headers. We'll discuss first about headers, then security headers like CSP, XSS, HSTS, and other security headers. Actually, headers are part of HTTP messages, which are composed of 4 parts: request line, headers, blank line, and body. Headers are case-insensitive key-value pairs. They carry or pass some specific information to the other end. So the web browser send information to the web server, and web server responds back to the web browser. So here is an example. The request is first part is request line, consists of request method, the path, then HTTP version, then is followed by the header field, then the empty line showing that the header field is finished, then the body. And here's the response. It is the response first the HTTP version, then the status, it's failed, then the header, empty line, body, which is like the body. Here it's called the request response cycle. Let's see some. Let's see like BSU. We can see. Let's see if we can we can see our LMS website headers. Then press F12. Then we can see network. So for example, this headers, XSS protection, like encoding, this response headers, and here is the request headers, and we can see that this response header here, it is exactly the same as the response, the same form. So this is an example just of headers. So here, after we had some knowledge in this in the header, let's go into deeper into security headers field. So security headers are headers, but they are constrained, adding constraints, a specific instruction, trying to reduce, mitigating some attack vectors. So like XSS clickjacking attacks, trying to reduce them. So the first security header is CSP. It's considered as the most important one because it has a lot of directives, it has a lot of options, but it needs a lot of experience actually to use it in an efficient more efficiently. For example, why it's important? Because it's restrict from where you can load your resources. It only like from where, just specific domains. So here, for example, the most used directive are default source and script source. Here it means load everything from defined source, and here means load just only the scripts from defined source certain domain. So here, if you request like file.js, it will respond it back because example it's defined in our CSP security header. But if you respond it, or if you wanna like load like xss.gss file on your web server, it will not allow to, because malicious is not like a source that our server is allowed to load its resources from. So this CSP, or actually all this headers, can be implemented using three ways: either by editing the file configuration of the web server, or by adding the htaccess, or or hard coded in the like programming language that you use in, for example, like PHP. So we'll add this security header using by editing the file configuration of the web server. Let's go to our web server path, exam apache configuration http.config. So here, this is the security header CSP that I added. Just should remove, then save, then but after any change in the file configuration of the web server, you should restart, then restart it again. Let's see. So here F12 again, and this is CSP. Self, it means just from the local host itself. So here it means load everything from the local host. It's allowed. So this is the first security header. Let's move on. The second security header is XSS. It's designed to defend against only reflected XSS vulnerability. It had like 4 options: 0, 1, 1 mode block, 1 report. Here it's mean disable, here it's mean active, just as a default option. It removes the unsafe parts. Excuse me. And here we will block all the page. It means that you cannot even render or load the page if you were trying to like some XSS payloads. And here, if someone tries to do XSS on your website, it will report it to to this website, but it's only compatible to the web server web browser, sorry, that are based on Chromium, like Google Chrome, because not all the web browsers are compatible with certain headers. Like for example, Firefox does not support the XSS header. So here how to add it, just let's here, so we add it by editing the file configuration as the previous one. We should restart it again. Let's see. So if we wanna try like script, look here, submit, it will not render. But here also Chrome has like XSS mechanism editor, not only the. But let's see. Here it's XSS protection. Reflected means that just it is like here we can see. Why it is reflected, I will tell you why. For example, here, if you put this the same script injection, it work. Why? Because Firefox unfortunately does not support XSS header, so it will work. Here we should consider the compatibility of the browsers. So let's move on. The third security header I will talk about is HSTS. This security header designed to force the browser, when it connects to my website, the connection should be established over HTTPS only, not over HTTP. So it has 3 header options. Max H, it means that for how long in seconds the web server should deliver through HTTPS, like it means just for like example 3 days. So after that the web browser can access my website through HTTP. includes subdomains, it means that not only my domains like google.com, but also my subdomains like drive.google.com. Here preloaded if I have like preload option, it means that web server will tell the web browser, so please let me inside your list. So whenever you want to connect to me, you should connect me over HTTPS only. So this actually increases the performance. So how we can this is like an example demonstration. When I request my website using HTTP, the web server will respond by HTTPS. So this is how we can use it, like just here. So just here and here it's sorry, here now it's working, but as usual I should restart the exam. So this is the third one. Let's continue. The X-frame option is actually this security one of the most important security headers. Why? Because it's restrict which sites are allowed to frame your web page. This prevents clickjacking vulnerabilities. Let's first talk about what does frame means. For example, this is just what does it mean frame. So here it is a frame, just like website inside a frame. We can inspect the codes just like iframe HTML tag, normal, no problem at all. But when clickjacking comes from, it comes from when I use it like that, like here. Actually, when you give like a victim like a link, and the victim, oh, this, when he see his your link, oh, it's normal page, nothing suspicious. So whenever or once he clicks on it, so his computer will be hacked. Why? Because once he click on it, he will transfer or redirect it to another website, and this website might be harmful, might download a malware on his computer, and his computer will be hacked. Why it's happening? Because let's inspect the code. So here I have actually one website which is hidden, or a division. It has like just a hypertext. So this hypertext or all the division will be hidden, and this will be on top of a normal website. So the victim will see the normal website, but actually on top of the normal website there is actually a division that's transparent. So whenever he clicks on it, he will not click on the normal website, but he will click on the hidden website, or the hidden website, which may be harmful. So here the iframe is actually so dangerous because it's allowed, so you must deny it. So the attacker cannot frame your website. Here this website does not like use X-frame options security headers, so I can frame his website. So it has this as X-frame options has three options: deny, same origin, allow for home. Deny, it means disable, so anyone cannot frame your website, and this is the best option. Same origin, if like for example Google can frame itself, like drive.google can frame Google or other subdomains. Here if just google.com is like for example allows Facebook to frame its website. So here it's used just comment like that, it will work. Actually the value of the header should be between quotation, and here is the key, and set it is like the keyword should be put it with the header to mean that this header should be established. And set means that if it has some previous value, just remove the previous value and update to that. So the fifth one, X content type option, means that if your website, like for example, if website like if it has like, and whenever I request something, it should, the responder should have content type, which means that this page, it means that HTML. Okay. For example, let me talk about like here. What about if I request like image.jpg, if I want to upload like a image to a website, and the website, it has like content type, it's like image png, but the image actually itself, its content is not an image, it's like it contains HTML. So here, when the content type is image, but its content, the image itself is not an image, it's HTML, the browser will sniff, will guess, will like see its content. Oh, and the browser will see that its content is not an image, it's HTML, so it will treat it as an image. So what as an HTML. And what about if the HTML contains some JavaScript? So this will really be harmful. So let's see here. Here is some multi-purpose internet mail extensions. So here so here X content means that if the HTML tag does not match the content type, so it will not be allowed to load it, this resource. So here no sniff, so don't guess its content, just based on its extension. So here, if it's image, so GPG, just GPG, don't see its content, don't see its code. So this will try and say. The last one is cookie setting. We'll set cookie setting like when, like, if your website is vulnerable to XSS attack, the attacker could easily like steal your cookie. So here, if we have like set cookie security header, it will really reduce this reduce the danger level of this attack. If we put like HTTP only, even if your website is vulnerable to XSS attack, the attacker cannot access your cookie by using JavaScript, because we are using HTTP only, and security means that cookies should only be served over HTTPS, so it means that no man in the middle. Same site is actually not it's not that best choice. HTTP only and secure are more important, and how to use it, just like that. And here we should put semicolon, because we're gonna combine HTTP only with the secure. This is why. So here, if someone could, like for example, redirect you using XSS vulnerability to a cookie stealer, he will be easily, like, let's see, he will easily like cookie, and he will steal his cookie based on, it's just really just a three lines. It's really easy so to steal your cookie. So here's some other cookies, like refer policy from where you come from. For example, cache control, to control the cache, if it should be stored for how long. Here to force, like web server will tell the web browser, so please make a public key for me. It tells him to. So website will have like public key for web server. Here, if your domain like should load some resource from different domains. Here some resources that I have used in my presentation. Really, I hope you got some benefits. So I hope it was beneficial to you, and thank you for listening.
Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to talk about my Python project. Moving on. First thing I'm going to discuss the main outline. First thing is this cybersecurity. I'm going to talk about briefly what is it, the languages to use in cybersecurity. Then I'm going to talk about the background, why Python language is important, why Python is the top choice, so this is considered as the advantages, Python flaws as the disadvantages too, and then I'm going to compare Python to another programming language. So what is cybersecurity? So cybersecurity is just protecting the internet connected system, including hardware, software, and data from a cyber attack. So what are the best languages to use? First, I'm going to talk about C. So whenever asking people about which programming languages to learn, experts often bring up C as one of the possibilities. That's because most operating system languages based on C. Assembly. If you plan to specialize in exploit reversal or understanding more about malware, consider assembly, another one of the most known languages. Like C, it's another relatively simple language, but people who understand cybersecurity say it's worth having under your belt. And lastly, and not least, our main concern, which is Python. Python. So, learning a programming language gives you an edge in cybersecurity. It allows for a deeper understanding of how application functions. Having these capabilities increases your chances of recognizing vulnerabilities and figuring out how to fix them. Cybersecurity experts can use Python to create attack simulation, build intrusion, detect systems, and can scan wireless network without depending on third-party tools. Python is one of the programming languages of choice, best of choice for people working in cybersecurity field. It's easy to learn and high performance too. So, Python was created between 1985 and 1990 by Udo van Rossum. So Python has a design that focuses on a code reliability and allows a programmer to write a code in fewer lines as compared to other languages like C++ and Java. It has an automated memory management system that allows it to support numerous programming prototypes such as functional, imperative, and procedural. As it sees in here, as written here, the latest research by Spectrum shows that Python ranked #1 programming languages this year. And to spoil the fun, so #1 Python compared to the other programming languages. So now we're going to why Python language is important. Programming is most important part of cybersecurity. So to become a cybersecurity professional, you need to know the languages like Python, Bash, C++, and so on. Python plays a very important role in cybersecurity. It is a scripting language which can be used for web programming, and it can also be used for a desktop application. It can also be translated into a binary code like Java. Hackers, penetration testers, and other security experts need languages library that provides them an entire spectrum of features to create a powerful and often novel programs. Python comes with a modules to support web activities such as HTTP and XML and building clients. Django and other open source web frameworks are available from developers favoring the rapid application development methodology. So we'll move on to why Python is the top choice. We can consider this as the advantages. So it's easy to learn. Python, like Java and C, much easier to learn as compared to many other programming languages. Easy to debug, since Python as a programming language that uses a minimum code, it gets easier for the programming to debug error as well as reduce the risk of getting any compiling issues. So it's wide use. Python has been widely used. It rather has an extensive use in power and other used power numerous web projects like Google, YouTube. It's object-oriented learning. Python enables an individual to gain an understanding about the several other object-oriented languages such as Java, C++. All one needs to learn is just the syntax of a new language. Open source language. Python is available at a zero cost of developers. This is a turn makes it a preferred choice of among many other developers and companies. Moreover, the language is so simple that it uses and increases its appeal to a smaller items. It has a high performance. The high performance that the Python is used just limited to help business grow and attain results, but it's also very useful to develop that fast application. It's also extensive support libraries. Python is available large standard libraries that are inclusive of options like string operations, protocols, internet and web server tools, and etc. Since the large number of code are already written in Python, so this in turn puts the limits to the length of code that needs to be written in Python. So improved programming productivity. The productivity of the program also gets improved due to reduced length of codes and object-oriented codes. It features such as process integration, unit test framework, and ability to manage, enhance, control, help, and the increasing of the speed of the entire application. And nevertheless, user-friendly for data structure, a built-in list and a dictionary that structures. Python allows the developers to reduce the length of high-level data typing. This turns help to reduce the length of support code that is needed. Now I'm going to talk about Python's flaws, or we can just say that the disadvantages of it, the vulnerabilities that we can see on Python itself. So writing a secure code is hard. When you learn languages, a module or a framework, you learn how it's supposed to be used. When thinking about security, you need to think about how it can be misused, just the same as we learn in the class. So Python is no exception. Even within the standard library, there are documented bad practices for writing a handed application. Yet, when I've spoken to many Python developers, they simply aren't aware of them. So I'm going to talk about the two most common, or the top two Python vulnerabilities or flaws. So let's move on. So the input injection. Injection attacks are broad and really common, and there are many types of injection. They all impact all languages, frameworks, and environments. So let's talk about first thing, the SQL injection. Is where you're writing an SQL query directly instead of using the ORM, mixing your strings literals with variables. It isn't familiar. It isn't familiar. You must familiar yourself with the complex ways of SQL injection and how it can be happen with these characters in order to prevent it. So the second thing is the command injection. Anytime you're calling a process using a pop-in sub-process and taking it augmented from the variables, when calling a local command, there is a possibility for someone setting those values to something maliciously. For example, let's go to imagine this as simple script credit. Let's go. So imagine this simple script credit. You all sub-process within the file name as provided by the user. So this is an example. Sorry about the scratch. So we can see that this is a command injection by which it affected Python itself. So we can set a value of a familiar name by this way, as you can just add a name or add a password into the quickly, as in to make it a dangerously maliciously way to it. Moving on to the second thing is how did they fix it? Python nevertheless, they fix things very quickly. So they identify the problem and they try to sanitize the input using the utilities that comes with your web framework. If you're using one, unless you have a good reason, you don't construct an SQL query by heart. Most ORMs have built-in sanitization methods. For for the shell, use this command, the shellx model, to escape input correctly. So, moving on to the second part of Python's flaws is XML piercing. If your application ever loads and presses the XML files, the odds are you using one of those XML standards library are modulus. There are a few common attacks through XML, mostly denial of service, designed to crash the system instead of exfiltration of the data. Those attacks are common, especially if you're piercing externally, not in a toasted, not in toasted XML files. So this is the first one, denial of service. So the second one is the billion laughs. So one of those called billion laughs because of the payload normally containing a lot of billion of LOLs. So laughs, they're laughing. Basically, the idea is that you can do referential entities in XML. So when we're unassuming XML tracer tries to load this XML files into your memory, it consumes a gigabyte of RAM, and trying to writing down the script for laughing. So this is the example of it in the code. So most of the people, though, they didn't believe it, so they tried it themselves, and it works. So another thing is that the attacker can use an external entity expansion. Entity expansion. XML supports refreshing entities from external URLs, and XML would do. Typically fetch and load that resources without any columns. An attacker can bypass the frame wall and gain access to the restricted resources, as all requests are made from the internal and the trustworthy IP address, not from outside. So another one is the third party package, or you can say packaging. So you're depending on that decode XML, like configuration file, or remote APIs. You might not even be aware that one of your dependencies leaves itself open to these typical types of system. So what happened in Python? Did he solve these problems while facing it? So the standard library models it reads, so they're trying to fix it. So when fixing it, so they use a diffuse XML as a drop-in replacement for the standard library models. It adds a safeguard against these types of attacks. So they trying up to date to find any flaws or any vulnerabilities to stop them, because they know that a lot of people depends on their security. And now I'm going to talk about Python. I'm going to compare it with another programming language, which is Java. I've chosen Java as another one because I'm familiar with it. And when I've surfed the internet, I saw that a lot of people have been talking about Python versus Java, comparing to each other. So we're going to start up and showing which is better, which I've done. So Python versus Java. Let's start with the productivity. So the developer productivity. One of the most important difference between Python and Java is that Python is dynamically typed. So whenever Java is typically typed. So this means that in Python itself, it is not necessary to declare the type of the variables when writing a code. Python is also popular and well known for being concise and readable, allowing the developers to do the same thing with a fewer lines of code. So let's do a thing, just you can bear with me. So this is one for Python and nothing for Java. For productivity, we're done with it. So Java has the win. So let's go for speed. So Python is an interpreted language, whenever Java is a compiled. This means that if speed is the primary concern of your project, neither language particularly shines on that era. between the two of them, of course. So this is 0 for Python and 0 for Java for speed. So let's go for community and library support. Python and Java are open source languages with a huge vibrant contributes to the languages themselves and offering support. Both languages come with an extensive array of library that are also supported by the countless talented of developers. So both of them win this part. So which language is best for application? Well, while Python and Java share many similarities and have different range of uses, they are not equally to every type of project. So, in addition, weighting up to the general pros and cons of these languages, Python will shine in this part of developing an application, which consists of many languages, and it's good for this job, and it can handle it very choosingly. So this is 1 for it, 0. So speed and budget. Python really comes into its own when its speed of development or budget are important into your project. So when it comes to the myriad of web framework available, it consists of code, plus in fact that it is dynamically typed, mean that it's possible to build and develop an app in a record time, which also has a benefit of lowering development cost. So this will help in development time when doing a project that we're studying in our software engineer. This is particularly available when you want to release an application under minimum available productivity model or build and test a prototype. So this is 1 for Python, 0 for Java. So mobile development, one of the Python drawbacks is that it's not native to mobile environment, neither to the major mobile platform. iOS and Android support Python as the official programming languages. For Java, it will shine on this part typically because it has a very rich use of experiences. Java, on the other hand, is also one of the preferable languages when it comes to the Android application development. So this is 1 and 0 for Python. So let's go for our main concern, which is security. So whenever security is a high priority, Java may have an edge on that. Although a good programmer can write a very secure app in Python, Java is commonly used for banking web application due to the particular strength of security functionality and environment. Java includes access to creation security features such as cryptography and advanced authentication and across control that keeps the web application secure. Also, Python will make it the top of choice of. Also, that Python and in this matter of choice will make it the top choice among the fine tech companies in developing a secure productivity. So both of them in security will have 1. So machine learning, combination of ultra powerful special libraries and general flexibility mean that Python is a way to go when it comes to a project that have a bias toward data science, deep learning, machine learning, and image recognition. So this is 1. So bringing everything together, Python and Java, two huge popular programming languages, are similar in many ways, but that does not mean that they both are equally suitable for every project. Choosing the best programming language for an application or in a ways, it comes in a lot of pros and cons of each language's machine. Python shines when it comes to development productivity, allowing a rapid development application, and what we can say, security, it can work too, and we can go with languages is the best for application, community, and library. It's not that much with speed, but the security is preferable. So the tally for both of them, we can say 1, 2, 3, 4, 5, 6, 6, 2, 3. So Python wins. This is my end of my video project. We'll continuing talking about Python. I hope you have enjoyed, and please subscribe and like, and any comments, and thank you very much.
Hello everyone. Today I will talk about Android permissions, how to achieve security by using them, and what are the security threats by exploiting them. So firstly, what is the purpose of permissions? The purpose of a permission is to protect the privacy of an Android user, to protect developers from being accused of exploiting Android features, to protect against malicious apps from harming the system. So firstly, to protect the privacy of an Android user from being exploited by apps. So for example, a video game recording voice notes or something without the user knowledge. To protect the developers from being accused that they record users and things like that. Also to protect against malicious apps that try to harm the system. So if the user downloaded something harmful, this app has to be granted permission to actually harm the system. So instead of impacting just upon downloading. Android apps must request permission to access sensitive data, for example, personal contracts, access system features like the camera. Depending on that feature, the system might grant the permission automatically, like accessing the cellular network state. So if the network is on or off, things like that. Or prompt the user to approve the request, like sending an SMS. Okay, type of permissions. Normal permissions doesn't require user agreement, like accessing the cellular network state, accessing notification policies, and accessing Wi-Fi state. So not the Wi-Fi, like changing the Wi-Fi, just see the Wi-Fi is on or off. Dangerous permissions that require user agreement, like accessing the calendar, accessing the camera, accessing the contracts. So impactful things. Custom permissions these require user agreement as well. These are permissions defined by the developers to access other apps and vice versa. So basically turning the app into a feature of the Android system. So you can define that your own permissions to keep you safe, or also to keep you to allow other apps to use your system, features from your system, not your system. Okay, type of requests, runtime requests. These developed in the new Android systems. These permissions come during runtime, and only when the specific feature is needs to be used. Also, this type of requests can be turned on or off. Like you can deny the permission after granting the permission in the settings menu. Install time requests, the older version of permissions. This only prompts when you install the app, and shows just the list of features that the app require. This type is more dangerous because it can be the feature can be used instantaneously after installing, while the other runtime requests, no, the user is prompted when the feature will be used. Also, this cannot be denied after installation. So basically, you need to uninstall the app if you wanted to stop using the feature. You can't have it another way. So now, how to do permissions? Okay, so this application we will use now is a application for to take a picture and then add it into from the external storage and read from the external storage. So now we will implement the permissions in this application. First, we say uses permission, and firstly we will need internet, so we use internet permission for internet. Uses permission, and we will add the external storage, which is read and write. Okay, you read and then write. And now we'll use permission for the camera itself, to use the camera. At this point, this is the old Android way. They will just, we do that, and in the insertion time, it will tell the user what permissions that the program need. But because this is a new Android application, we will need to implement it inside the code with the permissions itself. So we go now and add a new method. We call it verify storage, or we can do it all the permissions also. Verify permissions. Okay, so now we will do firstly log to see to talk about asking for user permissions. Now we'll create an array of the permissions and add each permission that we need. Firstly, we add it from the manifest, and the manifest.permission delete external storage, the manifest.permission write from external storage, and manifest.permissions add and we add the camera all the camera. So now we will do an if statement to see if the permission itself has been granted before. We say context.compact check self permission. This will check if the permission has been granted or not. So get the application context and then permissions, the array. We see the index and then use the package manager and permission.granted, and we will repeat this for each permission. So we just copy, see, change the index, then repeat it for the third one, which is the camera, change the index. So this if statement will check for if the permission has been granted or not. Okay, if they are, we just set up the view pager. And now else we will check for the permissions. So verify permissions here. So nothing will happen unless we have verified the permissions. Okay, remove this now, and activity compact request permissions to request the permissions itself. So firstly, we will use search activity, then permissions, then request code. The request code itself, just define it in the top. Final integer request code, and type anything, it doesn't matter. Request code, paste it here. This request code just will be used to catch the request itself. So we won't really, it doesn't really matter. So now we will do on request. So we will now catch the request code and verify if what the user said. So there we will say the setup view. Verify. So we will call the previous method, which is verify permissions, and check if the permissions have been granted or not. So this is how to handle permissions. So now we will test it. Okay, error. The error. Oh, the request code. Oh yeah. The request code can't be too long, so just change it to 2 or maybe 1. Just follow the best practices. Okay. Now, when we run the app, it asks for permission directly, allow or deny. So say allow and allow. Now we have allowed the permissions in our app. Okay, now best practices to follow when doing permissions to keep you safe and also to keep you from reliability. Firstly, only use permissions necessary for your app. So some developers you find them add all the general permissions without needing them. For example, a chatting app that requires SMS. Like if you are an online chatting app, you don't require SMS. or app that doesn't use the camera, doesn't have camera features, but uses the camera, for example, and these general things. This is a very bad practice, and that can harm your reputation. Also, pay attention to permissions required by libraries. So if you're using external libraries, check the permissions that they are using and try to implement them and see if they are using it correctly or just generally asking for them. Ask permissions when you need them. So if you are as you saw in the example I showed before, uh, you can ask for the permissions even during runtime, but ask them if, once you open the app, not when you are using the camera directly or reading from the uh, external storage. This is kind of bad practice. The whole idea of using permissions during runtime is to ask for them when you need them. So when the user wants to take the picture, ask for the camera permission. When the user wants to write something to the external storage, ask for the external storage permission. Use intent instead of permission when you can. Firstly, what's an intent? An intent is sending the function to another app to be handled, to handle it. So for example, if you want to take a picture, instead of implementing the camera inside your app and ask permission for the camera, just send it to the default camera app to be handled there. Or for example, if you want to use locations, instead of asking for permission for the location, send the user to Google Maps, for example, and let the other app handle it. So basically, give it to the other app. Don't overwhelm the user. This kind of contradicts with asking permission when you need them. If your app is asking wants a lot of permissions, try to gather them like how I did it before. The essential apps that the app doesn't work without, so you don't bother the user each time he wants to use a function. Just ask directly in the beginning, and if there is an optional feature, ask when you need that feature. Okay, now problems and permissions. Firstly, a big problem is when Android gets updated, they add some permissions may be added to your app without, so it will be added into your app Google Play listing, even if you don't require them. So you need to update your permissions and check them. And to see that, you go to build.version code documentation to see the newly added permissions. And sometimes the system doesn't allow multiple packages to declare the permission with the same name unless all packages are inside the same certificate. This happens with the custom permissions. So if you have a custom permission and you named it same as another app, conflict will happen, and the older app will remain, but the new app can't use this permission. So to avoid naming collisions, try to use the reverse name style in custom permissions. For example, com.permission.myapp dot the permission itself. So just put your app name to change the permission so conflict doesn't happen. Okay, another problems in permissions, future version of Android might move particular permissions to another group. So for example, read contract is the same group as write contract. So in the current Android, so if this read request changed, it's better not to link it with the write contract. So basically, don't assume the system will do it automatically. Grant the write contract permission separately instead of having it saying, oh, or they both group together. Just implement the group, because sometimes Android SDK change the permission grouping. So ask for the permission you need specifically, even if will be kind of repeated. So read contracts alone and write contracts alone. And that's it for my presentation. Thank you very much.
Assalamu alaikum. Today I'm going to speak about the security of add-ons. Now, first and foremost, add-ons. Add-ons are software components that extend the functionality of an existing software. They usually either add a new feature or change the appearance of the software. There are thousands of software that accept add-ons, and there are tens of thousands of add-ons to choose from. They are made by third-party developers, which means that security is not always guaranteed, since these developers don't always have security as their primary concern. How do they work? This might sound backwards to some of you, since we know that plugins are supposed to provide functionality for the host application. However, in order to do that, the main application must provide services through a services interface to the plugin. This is because a plugin is not a standalone application. It cannot work by itself. It needs something to work with, and those are the services provided by the application itself. Why do we need add-ons? They allow third-party developers to extend the functionality of the main software. They reduce the size of the base software. They also allow for easy extensibility, and they separate the source code from the application. Who uses them? Many software or types of software uses add-ons. We have audio editors, video games, text editors, graphics software, media players, and of course web browsers. All of those use many add-ons. Examples. Now you only need to search the word add-on on Google and you'll find many articles that speak about the top 10 must-have add-ons on your browser, for example. Those 5 are from the top 5 most used add-ons on the Mozilla Firefox page. We have AdBlock Plus and uBlock Origin, which both work to remove the ads that you see scattered around pages. We have Video Download Helper, which allows you to download videos from YouTube or other pages that host videos. We have Easy Screenshot, which allows you to take a screenshot of the website that you're on. And we have No Script Security Suite, which according to them protects you from cross-site scripting. Now, this is all well and good, but where does it all go wrong? One problem with add-ons is that it's made by a third party, which won't always have the security as its primary concern. This is because the add-on is made by a developer who wants to deliver a functionality. This developer is not a security expert. He just wants to do the job. He just wants the job done, and he just goes on his laptop. He types some code that works but is buggy. You insert it into your system as an add-on and it breaks everything. Another problem is there are tens of thousands of add-ons. This is a problem because you need to, as a developer, you need to protect your software against add-ons. You need to accept them to allow them to work, but you need to protect yourself against them. You don't need to trust them fully. And since there are so many, you can only provide the most basic protection. And some add-ons might require more protection that you're already providing. Also, there's the possibility that some add-on that you have might conflict with some other add-on that you want to download, which can create a problem for you. Another problem is that add-ons have as much authority as the user. So in other words, this breaks confidentiality in the CIA triad, since the add-on can access the personal data of the user. Also, any break in the add-on means that you have access to the system itself. If a hacker manages to break the add-on, he can manage to break the system itself. it also won't always be available since it's made by a third party and it's open source, so that yes, it's free, but it's fueled by the support of the community. If there is no support for it, it won't be updated much and it would become obsolete after a while. Another problem is that some add-ons require more access than needed. When downloading any add-ons, you see the list of access privileges that you need to allow them. Sometimes they are needed, sometimes they sneak in another privilege so that they have access to parts of data that you don't know about. Now here we see the OWASP top 10 vulnerabilities. We have at number 9, using components with known vulnerabilities. This, if an add-on is, or someone already knows how to break it, if you use it into the system, he's going to break into your system. And we have sensitive data exposure, which, as I stated before, it has as much privilege as the user that's using it. Now, for examples of previous vulnerabilities, we have Kodi. Kodi is an open source media player. It offers streaming services, and as other software other websites that provide streaming services, it doesn't allow pirated content. One of the leading add-ons of Kodi is called TV add-ons. It claimed that it would provide safety for any user who chooses to pirate a certain show. This sparked some conflict between the two, and it even reached the point where Kodi sued the developer who created TV add-ons. Kodi sent a warning to all users to stay alert with such add-ons. It said that you can use any add-ons that you choose, but Kodi are only liable for the add-ons that are verified by the company itself. In case you choose an add-on that's not verified by them and it breaks your system, it's your problem. Now, this is not exactly a break-in, but it goes to show how fragile the relationship between the software and the add-ons are. Say, for example, that the developer had a problem with the main software, so it has a lot of data that's accumulated through the use of its add-on, and it can release it anytime, which can create a lot of problems. Another example we have is for RForms. RForms is a builder plugin for WordPress. WordPress, as we know, is an open source service that allows you to create websites and blogs. RForms is one of the most famous and recently, in fact, it was in last month, it had a problem that allowed for arbitrary deletion of files. Now, this was patched, I think, last week, and we can see here that the exploit is detailed. The prompt tells you to please enter the WordPress URL as the first argument and the file address that you want to delete as the second one. For example, if WordPress is installed in the root directory of example.com, we want to delete the index.php. The exploit format should just be Python artforms.py example.com index.php, and just like that, the file is deleted. This exploit, as I said, was patched, and now we speak about how can we avoid trouble. And there are two parts to it. As a developer, you must make sure that the user is aware. As we mentioned many times throughout the course, you cannot protect the user from himself. You need to teach the user that what he's doing is dangerous for the system in order to actually protect him from himself. He can do some reckless actions or with the add-ons or with the software that will break the system. And as a developer, when you're adding a new add-on to your system, you should build a sandbox environment so that you can test all possibilities of what can happen, and in case something breaks the system, the main software is not harmed. As a user, you need to regularly check your programs, since some add-ons might, for example, decide to download some malicious software without your knowledge. Also, don't put all your eggs in one basket, which means that, for example, if you're using a certain browser and you're using add-ons, you should separate. For example, for your normal usage, you should use Chrome, but when you want to sign in for your bank, you should use Firefox, for example. Now, thanks for watching this video. I hope that I gave you some insight about security of add-ons.
Spring frameworks. So, Spring Framework. Spring Framework is an application framework and inversion of control container for the Java platform. The framework's core features can be used by any Java application, but it has become popular in the Java community as an addition or even replacement of the Enterprise Java Beans model. And the Spring framework is open source. So, in other words, Spring Framework is composed of a lot of different components. You have inversion of control container, you have the data access framework, transaction management, model view controller framework. You have lots of components, and it's become a core part of most like Java development, if you will. Like it's the most popular Java framework. It is used by developers. It's very important for web development, very important for application development. And let's see why it's so popular. So Spring is called the framework of frameworks. The reason is that all frameworks are supported by Spring, such as Struts, Hibernate, JSF, and likewise. Spring is very powerful yet lightweight. There is no need for a heavy Java EE application server. You can deploy its applications in any web container, even in Tomcat. There are still some exclusive features that other frameworks cannot afford yet, such as Spring. It operates faster, which is what we need. It's also developer friendly, has integration with front-end technology, aspect-oriented programming, MVC framework. As I said, there's a lot of things in Spring Framework. So what are the advantages of Spring Framework? It enables developers to develop enterprise applications, provides an abstraction layer on existing technologies, comes with some of the existing technologies like logging framework, JTK. Like it's basically, when you come install or download Spring Framework, it's basically a bunch of jar files that you will be using along with some models and MVC and the like. Spring Framework has a well-designed web MVC framework. In fact, Spring is considered as a mandatory requirement for a lot of web development courses outside. But anyways, Spring can eliminate the creation of singleton and factory classes because it basically does a lot of the things that you need singleton and factory classes for. So you won't need to create those separately. Spring provides a consistent transaction management interface, and this is related to security. And Spring Framework includes support for managing business objects and exposing their services to the presentation tier components against security. Spring Framework has taken the best practice that have been proven over the years in several applications and formalized as design patterns. So Spring is more or less, like the execution of a lot of design patterns and architectures, like already done for you, you could say. Especially security. Like there's a lot of websites that have high security requirements. They tend to use Java Spring Framework in some way to help, because it's basically used as a way to manage the relationship between different sort of authorities within, say, a website. Alright, Alright, so let's move on to be that this was all general, so let's move on to the specific how does Spring relate to security. So Spring Security is a framework that focuses on providing both authentication and authorization. So these are the main two parts that are related to security that Spring offers. The features are it has comprehensive and extensible support for both authentication and authorization. It has protection against attacks like session fixation, clickjacking, cross-site request forgery, servlet API integration. It has optional integration with Spring Web MVC and a lot more security requirements. Here's an example of some of Spring used with the database. So you could see here it's used for authentication. Here's all the code behind the scenes that does. They have the access denied page, have the authentication management. A lot of things that are done behind the scenes.
السلام عليكم ورحمة الله وبركاته. My name is Mohammed Al-Mandil, and as you can see in the title, today I'm going to present to you should you or should you not use PHP. What I'm going to talk about in this presentation, first what is PHP and what is it used for, and then I'm going to talk about the advantages and disadvantages of PHP, and then I'm going to answer this question if you should or you shouldn't use PHP. And I'm going to talk about the security of PHP, if it's secure or insecure, and I'm going to talk about its known vulnerabilities and the history of breaches and vulnerabilities and attacks that happened on PHP. Okay, first, what is PHP? The acronym PHP is a recursive acronym that stands for PHP Hypertext Preprocessor. PHP is a widely used open-source, general-purpose scripting language that is specially suited for web development and can be embedded into HTML. PHP is free to download and use, and it is the most used language for web development. 78.9% of all websites worldwide use PHP, which is a huge number in the web. This means millions and millions of websites use PHP. Okay, the advantages and disadvantages of PHP. And the advantages, first, it's easy to use and learn, especially for beginners. It has simple syntax, it's very easy, and it's even easier for people who know C, because the syntax of PHP is very close to the C language. Second, open source. In this case, we put open source in advantages because PHP has a very large community of developers. These developers can make add-ons to PHP or tools to make PHP even easier and more efficient to use for users. PHP has built-in database connections. PHP already has syntax and commands to connect to databases very fast. It's very easy to learn and use, especially for beginners, and this is what makes PHP different than other languages. And then PHP is cross-platform. PHP can be used on Windows, Mac, Linux, or any other type of platform, and it will work just fine. The disadvantages of PHP. First, it is not suitable for large applications. If you have a very large web and the application is very large, it's very hard to maintain it using PHP alone. And the major disadvantage is security, which is a very huge problem. Security is the most important thing in a software. Okay, now to answer the question, should you or should you not use PHP? No, you should not, because PHP is insecure. Security is a major key in software development. Security is the most important thing, because without security, there is no point of the software. So, PHP had many vulnerabilities throughout the years. It had many breaches, many attacks, that every time PHP puts a new version to mitigate previous vulnerabilities and threats, attackers would still find more vulnerabilities in the new version. And this keeps on repeat for over the years. Each time PHP makes a new version to mitigate the threats and vulnerabilities of the old versions, a new threat and vulnerability is found in the newer versions. Okay, so let's talk about the known vulnerabilities of PHP. First, SQL injection attacks. This has to do more with the users than PHP itself. Mainly, users think PHP is secure enough that it can handle SQL injections alone without the user having to input, validate, or do the necessary things to mitigate this attack. PHP alone is vulnerable to these attacks. The user should put input data validation and other ways to mitigate this attack. The next is XSS attacks or cross-site scripting attacks. This is the most used attack against PHP. Over the years, this attacks keeps happening and happening and happening, and they still can't mitigate it. With each version, there happens to be a cross-site scripting attack. Then, cross-site request forgery. This attack happens when a user is tricked to performing an act he didn't intend to do. For example, an attacker could trick a user to click on a link. When the user clicks on the link, there will be a PHP code in the background that replaces this user's email, and updates it with the attacker's email. And it's done. The attacker could then go to the website and put forget password, and the password reset will then go to the attacker's email because of this attack. The other attack is called stream injection attack or remote file inclusion. What is this attack? This is when, for example, I have a website, and in my website I use a library of a different website. It's perfectly fine for this, and this is considered an advantage in PHP. But what makes this an attack? If the library I use from the other website, if that website gets hacked or compromised or whatever, the attackers could manipulate the code of this library, which will affect me and deal damage to my website and my system. And then session hijacking, which is very, very common in PHP. It's when the attacker steals the user's session or cookies and then go to the website claiming to be that user. And then the SSL and TLS misconfiguration attack. SSL and TLS are like protocols that are used for communicating. The SSL TLS misconfiguration attack, it's like a man-in-the-middle attack. An attacker could be the man in the middle and see the communication that happens at the website. And finally, XML injection attacks, which are close to SQL injection and XSS attacks. They are very common in PHP. Okay, now we will talk about the history of vulnerabilities and attacks and breaches that happen to PHP itself. First, I will show you a list of the most recent vulnerabilities. These all happened in 2018 and 2017 on the most recent version of PHP, which is 7. Okay, the first one, this is the ID of the vulnerability, and this is the type of the vulnerability. The first one, the type is cross-site scripting vulnerability. Okay, this vulnerability, the description is an issue was discovered in PHP before version 5 and 7, before 7.0.27, 7.1, and before 7.1.13 and 7.2 and 7.2.1, which is the most recent version. This vulnerability, it says there is reflected XSS on the 404 page via the URI of a request for a .var file. So there was a vulnerability in this file in PHP, which was vulnerable to XSS attacks. Next, it's a denial of service vulnerability. It says in PHP before version 7.1, which is very recent, this vulnerability, remote attackers could cause a CPU consumption denial of service attack by injecting long form variables related to main PHP in this file. This file was vulnerable to DOS attacks. Yes, and this vulnerability had a 4.3 out of 10. This is the score of how high of an impact this vulnerability. So it's not very serious, this vulnerability. It only got a 4.3. But this, as you can see, it got a 7.8 out of 10. Okay, to continue on the most recent. This is also very new in the 7.2.8 version. This is an overflow vulnerability. So in this file, it says an integer overflow leads to a heap-based buffer overread. So in this file is vulnerable to overflow attacks. Okay, the final example that I'm going to include on the most recent vulnerabilities. This vulnerability is vulnerable to denial of service and overflow. It is on the most recent 7.1.7 version of PHP. It is a stack-based buffer overflow in this function in this file. Could cause a denial of service or potentially allow executing code. And it got a 6.8 score out of 10, which is considered high. And this overflow only got a 5 over 10 score, which is average. Okay, now this is a top 5 list of the most vulnerabilities that had the most high score. All of these lists got a score of 10 out of 10, which is the highest score, which means it has the highest impact on PHP. In the previous list, it was only the vulnerabilities on the newest versions, but this is a list of the highest impact over all the years of PHP. So, in the first vulnerability, it was the first ever vulnerability of PHP with a 10 out of 10 score. This vulnerability actually has no type. It's not an overflow or a denial of service, but a huge vulnerability. There is no specific type of it. It says php.cgi allows attackers to read any file on the system, which is very dangerous. And this was in 1997, 8.1. The next one is an executed code type. The vulnerability allowed attackers to execute a code on PHP. So it says PHP 3 and 4 do not properly cleanse user-injected format strings, which allows remote users to execute arbitrary commands by triggering error messages that are improperly written to the logs. This was in year 2000, month 12 and day 19. The next one is an overflow vulnerability. It says buffer overflows in PHP before version 4.3.3 have an unknown impact and unknown attack vectors. This also got a 10 out of 10, and this was the year of 2003, 11, and 7. And this vulnerability was vulnerable to DOS attacks and executed code attacks. It says the deserialization code in PHP before version 4.3.10 and PHP version 5 up to 5.0.2 allows remote attackers to cause a denial of service and execute arbitrary code via untrusted data to unserialize function that may trigger information disclosure, double free, and negative reference index array underflow. This was back in 2005, 110. And finally on the list is a vulnerability that is vulnerable to executed code attacks and overflow attacks. The description is buffer overflow in the exef read data function in PHP before version 4.3.10 and PHP version 5 up to 5.0.2 allows remote attackers to execute arbitrary code via long section name in an image file, and this was in 2005, 110. Okay, in conclusion, we have seen that PHP is almost used by almost 80% of all websites worldwide, which is a very, very huge number. We are talking about millions of websites that use PHP. We have seen the advantages as it's easy to use and it's a good, it has it's cross platform. It had many advantages, but all these advantages, uh, there is no point of them because the software is not secure. Because having uh, a very good software with many features and really good advantages, but it is not secure. It's like having a castle with valuable things inside, but it has no windows, and no doors. There is no point of it. Security is so what we conclude that security is very important in software, and it is the most important thing in software, because you have to remember just one line of code could damage your whole system and your whole software. And that is it for the presentation. Thank you for listening and watching. And if you have any questions or any inquiries about what I just presented, you are free to contact me. This is my email address. And thank you all.
Hello and welcome. In this video, I'll be talking about Cloudflare, a look into its vulnerabilities history, their impact, and their mitigation. I will be talking about what Cloudflare is, what it does and how it does it, one particularly harmful vulnerability found which was called Cloudbleed, its causes, impact, restorative and preventative action taken, and possible mitigative methods. Cloudflare is a content delivery network. A content delivery network refers to a geographically distributed group of servers which work together to provide fast delivery of internet content. Cloudflare, through proper configuration, offers distributed denial of service mitigation, internet security, and domain name services. Cloudflare's distributed servers act as an edge server between the client and the origin server. More explanation regarding edge servers will be provided in the next segment. It is a distributed network of servers that provides several advantages for a website. It caches web content. By caching website content, such as JavaScript files, style sheets, images, and so on, it allows for the quick transfer of data, improving page load speeds, and reducing bandwidth usage. It increases redundancy of resources. With a redundant network of servers worldwide, if a server experiences an issue, Cloudflare's content delivery network simply fails over and uses another server. It increases security. Cloudflare helps improve security by blocking threats before they reach a site, through proper configuration, and by executing simple checks on traveling data. Cloudflare's content delivery network can also provide some protection against distributed denial of service attacks. These distributed servers, called edge servers, exist on the logical extreme or edge of the network. An edge server often serves as the connection between separate networks. A primary purpose of a content delivery network edge server is to store content as close as possible to a requesting client machine, thereby reducing latency and improving page load times. For internet devices, the network edge is where the device, or the local network containing the device, communicates with the internet. The important takeaway is that the edge of the network is geographically close to the device, unlike origin servers and cloud servers, which can be very far from the devices they communicate with. In simpler terms, edge computing means running fewer processes in the cloud and moving those processes to local places, such as on a user's computer or an IoT device, minimizing the amount of long-distance communication. As user requests pass through these edge servers, protection against malicious attacks might be provided. This can be done through proper optimization of the edge servers, and through offering functionalities which ensure the optimization and security of, and from, passing requests. For example, Cloudflare's distributed denial of service protection services are done through monitoring user requests coming into the server, and are handled by limiting these requests. A major vulnerability that affected Cloudflare is called Cloudbleed. It was discovered in the middle of February of 2017. It caused the leakage of sensitive information across websites hosted behind Cloudflare. It was named Cloudbleed after Heartbleed, which opened the door for cybercriminals to extract sensitive data directly from a server's memory without leaving any traces, allowing them to read portions of the affected server's memory, potentially revealing users' data that the server did not intend to reveal. Cloudflare has confirmed that the grace period of impact was between February 13th and February 18th of 2017. With almost 1 every 3,300,000 HTTP requests via Cloudflare potentially resulting in memory leakage. While 1 in 3,300,000 may sound like a small number, consider the number of customers and users Cloudflare has to serve on a daily basis, and the number of requests each of them typically makes. Furthermore, there is reason to believe that the leak may have been active since as early as September 22nd of 2016, almost 5 months before Cloudbleed was discovered. The leaked data consisted of cookies, passwords, HTTP post bodies, HTTPS requests, and much more, all of which could be highly sensitive data valuable to the customers. The leaked data was also automatically cached by search engines, making it particularly difficult to clean up the aftermath, requiring the assistance of the third parties overlooking the search engines. As for the causes of Cloudbleed, Cloudflare used Ragel, an HTML parser, to parse HTML elements. Badly written Ragel code is where the vulnerability was, but the error causing the vulnerability to manifest was never encountered. A decision was made to gradually shift to use another parser, CFHTML. The introduction of CFHTML, as it worked simultaneously with Ragel, caused the implications of the vulnerability to manifest. It turned out that the underlying bug that caused the memory leak had been present in the Ragel-based parser for many years, but no memory was leaked because of the way the internal buffers were used. Introduction of CFHTML subtly changed the buffering, which enabled the leakage, even though there were no problems in CFHTML itself. It should be noted that the issue is not with Ragel itself either, but with the improper usage and implementation of Ragel code, due to the developer's lack of experience. Following is a technical overview of the root cause. In the above image, the Ragel code is converted into the generated C code, which is then compiled. The C code uses, in the classic C manner, pointers to the HTML document being parsed. The underlying bug occurs because of the pointer error. The root cause of the bug was that reaching the end of a buffer was checked using the equality operator, and the pointer was able to step past the end of the buffer. This is known as a buffer overrun. Had the check been done using bigger than instead of equals, jumping over the buffer end would have been caught. The equality check is generated automatically by Ragel, and was not part of the code that was written by the Cloudflare team. This indicated that the Cloudflare team did not use Ragel correctly. In the bottom image is a piece of Ragel code that is used to consume an attribute in an HTML script tag. The first line says that it should attempt to find 0 or more unquoted attribute characters, followed by space, / or a closing bracket, signifying the end of the tag. If an HTML attribute is well formed, then the Ragel parser moves to the code inside of the block at the beginning of the third line. If the attribute fails to parse, as is the case with our bug, then the block at the fourth line is instead used. In some circumstances where the web page ends with a broken HTML tag, the block at the beginning of the fourth line would get used, and the buffer would be overrun. If you look closely, you will notice that the transition block at the third line did an if goto, but right before it did an if hold. The block at the beginning of the fourth line, however, did not do an if hold. This lack of the if hold is what resulted in the memory leakage. The C code generated from the above Ragel code has a pointer named P that is pointing to the character being examined in the HTML document. If hold is equivalent to P and is essential because when the error condition occurs, P will be pointing to the character that caused the script consume attribute to fail in the fourth block. This is important because if this error condition occurred at the end of the buffer containing the HTML document, then the P will be after the end of the document, and the subsequent check that the end of the buffer has been reached will fail, and P will run outside of the buffer. This relates back to the generated C code in the above image, where the checking condition was equal instead of bigger than or equal. Going back to the Ragel code, specifically the fourth line in the block, had an if hold been added to the error handler, the problem would have been fixed. Here we can witness some of the discrepancies that caused the bug to emerge. The images in this slide show the buffers that will be passed to the parsing function when attempting to consume HTML elements with unfinished tags. The above image shows what a final buffer that contains data looks like when not using the new parser. Notice that the boolean last buffer is equal to 0. When both the old and the new parsers are present during the request handling, a buffer such as seen in the below image will be passed to a parsing function. Notice that that boolean last buff here is equal to 1, unlike the first image where it was equal to 0. The unexpected change in the last buff boolean has caused inconsistency in how the pointers function, which has made a bug that was dormant for years to finally manifest itself and cause the leakage of the memory. A few restorative and preventative actions were taken as soon as the issue was found. Firstly, the new features that were using the new parser, CFHTML, were quickly disabled. At that time, there were only 3 features that used CFHTML, which were the email obfuscation and the automatic HTTPS rewrites, and the third one, which was the server-side excludes. All 3 of these features were disabled. The email obfuscation feature was the primary cause of the leaked memory, thus disabling it quickly stopped almost all memory leaks. Additionally, Cloudflare worked with Google and other search engines to remove any cached HTTP responses. They ensured that this memory was scrubbed from search engine caches. They made sure to do so before the public disclosure of the problem, so that third parties that wanted to go hunting for sensitive information would not acquire that knowledge before it had went to the public. Possible mitigative measures that could have been taken include implementing subsystems to check the kind of cached data. Such subsystems would make sure that private, sensitive data would not be cached on edge servers, reducing the chances of such data being leaked from the edge servers. This applies both the defense in depth and the least privileged principles. Other than that, implementing subsystems to ensure the safety of data when compromised, such as proper encryption of data using strong encryption algorithms. Having such measures would decrease the chances of sensitive data being exploited, even if it's been acquired, due to the difficulty of decrypting it. This applies to the fail securely principle. Thank you for tuning into my video, and I hope that you have found it to be informative.